Rosalind Franklin is often celebrated as the quiet detective of the molecular world, a brilliant scientist whose sharp eyes and sharper mind could peer into the invisible architecture of life itself, turning ordinary tubes, crystals, and beams of X-rays into shimmering clues about the secrets hidden deep inside every living cell, as if she were solving the grandest mystery the universe had ever written. She was born in 1920 in London, in a bustling neighborhood where the air buzzed with trolley bells, chimneys puffed clouds that curled into the sky like lazy dragons, and children dashed through narrow streets that echoed with laughter, footsteps, and the rustling excitement of everyday adventures waiting around every corner. As a little girl, Rosalind wandered through gardens, courtyards, and school pathways with the quiet certainty of someone on a secret mission, studying rocks, seeds, feathers, and insects with such intense focus that adults sometimes wondered whether she could see details too tiny for anyone else to notice. She loved watching raindrops slip and slide down windows like tiny acrobats practicing daring stunts, their shimmering trails bending and merging as if performing a watery dance choreographed just for her curious eyes long before she understood the science behind their graceful motion. Her curiosity grew like an unstoppable vine, twisting happily toward the sun, blooming brighter every time someone tried to trim it back with a simple answer, and teachers frequently paused mid-lesson when she raised her hand to ask questions that were somehow deeper, sharper, and far more interesting than the material on the board. She gobbled up books about chemistry, physics, and Earth's hidden structures the way kids devour candy after Halloween, sometimes reading so intensely that she forgot snacks, chores, or even that she was supposed to be playing outside instead of running complex experiments inside her imagination. Her family encouraged her hungry mind, letting her explore ideas, challenge explanations, and push boundaries, even though they occasionally joked that she might accidentally transform the living room into a laboratory explosion scene if they didn't keep an eye on her. When she entered Cambridge University, she marched across campus with notebooks tucked under her arm and determination fueling every step, earning quiet admiration from classmates who whispered that she seemed destined to discover something important, something big enough to change how the world understood itself. She studied the structures of coal and carbon as if exploring hidden kingdoms made of shadows and atoms, uncovering patterns that revealed themselves like intricate blueprints whispered by the materials themselves, and her discoveries quietly reshaped the scientific understanding of how carbon behaved. During World War II, her research helped improve fuels that powered airplanes and machines, and although she rarely talked about her contributions, there was a deep pride inside her knowing she was using her scientific gifts to help during a moment when the world needed every spark of intelligence it could find. After the war, Rosalind journeyed to Paris to join a laboratory filled with lively discussions, clattering equipment, glowing instruments, and spirited debates that swirled through the air like excited flocks of intellectual birds, giving her a place where she felt instantly at home among fellow explorers of the invisible. There she mastered X-ray diffraction, a technique so sophisticated it felt like using light itself as a detective tool, capturing the secret shapes of molecules through delicate patterns of dots, lines, and shadows that only the trained eye of a scientist artist like Rosalind could decipher. She worked with the grace of a dancer and the precision of a clockmaker, adjusting instruments micrometer by micrometer, preparing crystals as if arranging tiny constellations, and revealing molecular structures that sparkled with scientific meaning even though they were far too small for any human eye to see directly. When she moved to King's College London to study DNA, she stepped into a laboratory buzzing with ambitious researchers and brewing rivalries, like a theater stage crowded with magicians trying to perform the final astonishing trick before the others could claim it first. But Rosalind ignored the drama swirling around her and focused entirely on science, preparing DNA fibers with near magical precision, gently stretching and aligning them, if coaxing shy creatures into holding still long enough for her to capture their portraits in X-ray light. Her legendary photo 51 was so clear, so symmetrical, and so revealing that it seemed like a secret message from the universe suddenly captured on film. An image so powerful that anyone who saw it felt a shiver of or run down their spine as though witnessing the blueprint of life whispering its shape for the first time. The photograph displayed a perfect X-shaped pattern that hinted unmistakably at the famous double helix, a spiraling ladder twisting upward as gracefully as a staircase. In a dream, and Rosalind, with her careful, calculating mind, recognized that this was not just a picture, but a doorway into understanding life's deepest architecture. She filled page after page of her notebooks with precise measurements, sketches, and calculations, mapping the mathematical heart of the molecule with the dedication of a cartographer drawing the first map of a newly discovered world rich with biological treasure. Even though others sometimes used her data without fully acknowledging her contributions, Rosalind chose to keep her focus steady, pursuing truth with the quiet integrity of someone who believed discovery mattered more than applause, awards, or arguments. She wasn't interested in rivalries. She was drawn to beauty, order, and the elegant patterns that nature revealed when treated with patience and respect. And she often stood silently at her lab bench while others argued loudly about theories she knew would crumble under the weight of precise data. Rosalind later joined another laboratory where she continued her groundbreaking work with viruses, treating each one as a delightful yet perplexing puzzle. Revealing their structures with the same calm mastery she had brought to DNA, uncovering their patterns like a detective examining clues left behind by microscopic tricksters. Her colleagues admired her honesty, intensity, and brilliance, amazed by her ability to slice through confusion and illuminate a problem with clarity so sharp it felt like watching fog lift from a mountaintop, all at once revealing the breathtaking view beneath. Despite her serious demeanor in the lab, she loved hiking, traveling, and exploring mountains with a sense of adventure that lit up her eyes, proving that even the most focused scientist can carry the joyful heart of an explorer who wants to see what lies beyond the next hill, valley, or distant horizon. Even during her illness, she worked with remarkable strength, producing influential research, mentoring younger scientists with kindness, and continuing to explore scientific mysteries with an unwavering spark that proved her curiosity never dimmed, not even for a moment. Her influence expanded far beyond her lifetime, growing like ripples across a vast lake as scientists realized how essential her discoveries had been in revealing the structure of DNA, an insight that revolutionized biology, medicine, and the way humanity understands the story written inside each of us. Today, Rosalind Franklin stands as a symbol of courage, brilliance, and relentless curiosity, a reminder that the quietest minds can sometimes reshape the world the most profoundly, uncovering truths powerful enough to illuminate generations. She continues to inspire countless young scientists, dreamers, and kids who stare at raindrops, crystals, or swirling patterns of light and wonder about the unseen secrets waiting just beyond the boundaries of what our eyes can detect. When we see DNA drawn as twisting spirals in textbooks, animations, movies, or glowing classroom posters, we are witnessing the echoes of Rosalind's work. Her careful hands, her remarkable vision, and her unshakable determination to understand life at its smallest scale. She taught the world that science is a grand adventure filled with patience, imagination, and courage, and that sometimes the greatest discoveries come from those who look closely, think deeply, and refuse to give up even when the path seems hidden or the recognition slow to arrive. Rosalind Franklin remains one of science's brightest guiding lights, her legacy swirling through history with the same elegance as the double helix she helped reveal, reminding all of us scientists and dreamers alike to stay curious, stay determined, and keep following the faint glow of mystery until it reveals something beautiful.